All right, so we're gonna continue with trig ratios today, and we're gonna look at we're gonna concentrate on non-acute angles. So if we go and remember some of our trig ratios here, in terms of, and really all we're doing today is we're trying to place the trig ratios in the context of our Cartesian plane. So sine theta we know is y over r. Cos theta is equal to x over r. And tan theta is equal to y over x. Okay? And so really the only difference between doing trig ratios in the first quadrant and the ones that are non-acute is which quadrant they set us in. So if we remember that our hypotenuse of our special triangles is always going to be our radius, and our height, or our opposite side of our angle, of our triangle, is always going to be our y, and our adjacent side is our x. We can find that out pretty quick. So let's just go and take a look. If we're in our first quadrant here, all of our trig ratios are going to be positive because y is always positive, x is always positive, and our radius, doesn't matter which quadrant, is going to be positive. So it doesn't matter what we have in here in the first quadrant, all of our trig functions are going to be positive. So the reciprocal functions as well, if we for cosecant and secant and cotangent, their signs aren't going to change if we take the reciprocal of these trig ratios. So all of our trig ratios are going to be positive there. Okay. If we move into our second quadrant, okay, here y is still positive. This is still a positive y, but now x is negative. Okay, so if we go and make x negative, it looks like cos is going to be negative. Let me go in here because a negative over a positive is going to give us a negative. Tan would be negative because y would be positive, but x would be negative. But our sine function would still be positive because my y is positive and my radius is always positive. So sine theta and cosecant theta are going to be positive in this. Okay, so let's go and take a look over here. Let's see what I'm going to get. So looks like here my x is still going to be positive and my y though is going to be a negative value at this point. So it looks like I'm going to get a negative value for sine but a positive value for cos. So cos theta and secant theta are both going to be positive here. And last but not least, we'll go over to this quadrant. Okay, and here I'm going to have a negative x and a negative y. So the trig function that's going to be positive in that quadrant is going to be tan because both x and y are negative, so it's going to be positive in that quadrant. So a nice little acronym to help us remember which trig functions are positive in which quadrants is this, is the cast. So C, meaning cos, and its reciprocal secant is positive in this quadrant. A, for all the trig functions are positive in quadrant 1. S, for sine is positive in that quadrant along with its reciprocal cosecant. And T, spelling cast. Okay, it's just a nice little way to remember which trig functions are positive in which quadrants. Okay, so let's put this to work here. Determine if the value of each ratio is positive or negative. So what we want to do is map out our angle. So sine of 240 degrees, 240 is 60 past 180, so it's going to be here in this third quadrant. And I can see that only tan is positive in that quadrant, so this is going to be negative. Okay, cos of 5 pi over 3. Well, I know that a full circle would be 6 pi over 3. So 5 pi over 3 is pi over 3 less, or 60 degrees less, so that puts me in the fourth quadrant. So cos is positive there. Okay, and last but not least, tan at 150 degrees. Well, 150 degrees puts me right here, third of before 180, right? It puts me in the second quadrant there. So sine is the only, sine and cosecant are the only trig functions that are positive there. So tan is negative. Okay, so let's put these two skills together here. So what does this say here? Okay, the value of a trig ratio can be found using the reference angle and the sine for the quadrant. Okay, so if we remember our three special triangles, okay, so let's do pi over 3, and if our radius is 1, that means that our height is a half, and that our length here is root of 3 over 2. And if I, oh, whoops, that should be pi over 6. It's a mistake, pi over 6. Let's do pi over 6 down here. And this is really the same triangle, right? It's just set on its side. This is pi over 3. Okay, and this changes to root of 3 over 2. This length is a half, and this length is 1. And finally, our last triangle, pi over 4. If our radius is 1, I'm going to have root of 2 over 2 as this length, and root of 2 over 2 as that length there. Okay, so what we're going to do is we're going to try and map these three triangles onto our Cartesian plane, and then we're going to figure out, so we'll have the values of x or y, and then we'll look at our cast to help tell us what our sines are. Okay, so sine 330, let's try this out. So these eventually you're going to want to simply memorize. But right now, let's just try and take a look at them and see about the things that you should be thinking about when you go to do this in your head. Okay, so sine 330 is 30 degrees before 360, right? So it's going to be in here. So that picture is going to be this 30 degree triangle in this quadrant, right? So here is my reference angle of pi over 6, or 30 degrees. And so this height, it's still the same triangle, right? So this is going to be minus a half. This is going to be root of 3 over 2, and this is going to be 1. And we know that sine of theta, any angle, is going to be our y over r. So sine of 30, I guess, or pi over 6, 30 degrees, is going to equal our y minus 1/2 over r, or simply minus a half. Okay, and so does that make sense? Sine is definitely supposed to be negative in our fourth quadrant, so there you have it. Okay, so for this next one, cos of 5 pi over 4, we know that that's going to be focusing on a pi over 4 triangle, right? And it's going to be in the third quadrant. 4 pi over 4 is here, so 5 pi over 4 must be in here. So this triangle is going to slide into here, and this is going to be minus root of 2 over 2. Same as here, minus root of 2 over 2. And so cos in this spot is going to be our adjacent over our hypotenuse, or x over r. So cos of 5 pi over 4 is going to equal negative root of 2 over 2, and then over 1. Okay, so really this is our final answer. Negative root of 2 over 2 over 1 is negative root of 2 over 2. Okay, so that's the idea. Looks pretty good. So I'd like to say there's more to it, but there really isn't. all there is now to kind of work on is how fast you can do this, and some of these you want to kind of almost be able to memorize. Okay, so let's just look at this one real quick. So the way you should be thinking is sine of 225. What reference angle does that represent? That's a 45-degree reference angle, right? So 45-degree reference angle for sine is going to give me a value of root of 2 over 2, and then by using cast, I can think of which quadrant it's in. It's going to be in the third quadrant, so that must be a negative value. Okay, so that's kind of doing it without the picture. Okay, here sine of 120 is going to be a reference angle of 60 degrees. Okay, and so I know my value there. Sine means the y, so it's the high part of the triangle, so it's going to be root of 3 over 2 is the value, and 120 is in this quadrant here, so sine is positive there, so I can leave it the way it sits. Okay, I guess a little different are ones that are on the axis. So let's give a try at cos 3 pi over 2. Okay, so I know 3 pi over 2 is here, and that point is the point 0 and negative 1. So I know that cos is going to be my x over my r. Okay? And so here, if I go x over r, the x is 0, and my radius is 1. So it's going to be 0 over 1, which is equal to 0. A tan angle, okay, the ratio of tangent at a certain angle is, I guess, a little trickier because here I'm going to map out 11 pi over 6 is in here, right? Okay, and it's a 30 degree triangle, or a pi over 6 triangle. That's my reference angle, and so that means that this is going to be my half distance, but because it's in this quadrant, it's minus a half, and this distance is going to be root of 3 over 2. So tan is y over r, so it just means that I'm going to have to divide negative 1/2 over root of 3 over root of 2 and simplify that out. So it looks like I'm going to get negative 1 over root 3, and to rationalize it, multiply that by that convenient 1, and I get negative root of 3 over 3. Okay, so I'm going to leave these two for you as an exercise, and we'll just pop over to the next page here and see if there's anything that looks really super scary here. Okay, so these are the same questions, except they're simply with some of the reciprocal angles. Okay, so for example, let's look at secant of 7 pi over 4. Now secant is the reciprocal of cos. Oops. Secant is the reciprocal of cos. So, and we know cos of theta is x over r. So secant is going to be r over x. Okay? And that's a 45-degree angle in the fourth quadrant, right? There's 7 pi over 4. So this is going to be pi over 4 in here. So secant, my radius is 1, and my x is going to be positive root of 2 over 2. So that gives us 1 over root of 2 over 2, which is going to be equal to 2 over root 2, which is simply equal to what after you rationalize the square root of 2. Okay? So I'm going to leave the rest of that page for you as an exercise. Make sure you get those done, and really concentrate on trying to figure out how to put those three main triangles, three special triangles, into the different quadrants and how it changes the signs. And then you should be rolling for next day. Cheers.